Okay, can everybody see my screen?
Yeah.
Yes.
Cool. Okay, well, let's get started. We are going to start in this phone book directory here. And we have several lessons / exercises here where I'll just tell you ahead of time, we're not going to get to all of them. We always start, the phone book is the most introductory one.
Hey, Jack.
Yes, sir.
Sorry, question. Jake said that you had updated the GitHub files yesterday.
Yes.
So some of us had forked over and Git cloned last week or yesterday morning. I'm wondering, how do we ensure that we have the latest version? Because GitHub is not allowing me to fork it again.
Yeah.
Okay.
Oh, sorry.
Go ahead, Jake. You might.
No, I feel bad now because you all were like really proactive by doing that early, and now because of approaching this change, you're gonna have to do something very common, but maybe you haven't done before. So if you fork the repository, there's always like two choices with something like this. You can clone or you can fork. If you clone, then you don't have a copy on GitHub that's yours. But that's okay a lot of times because you don't always want your own copy, right? Like you only need your own copy if you're going to be pushing your own changes up to GitHub and you want to save them. So if you if you fork the repository though, then you're going to have to do this thing where you get changes from the upstream, it's called, which is our repository, and you put them in your version.
Okay, well,
I think, sorry to interrupt, but just for the sake of simplicity, I think it would be easier just to create a new folder and git clone the repo again into that folder.
yeah, I'll just do that. I'll just git clone off of the master. Thank you. Sorry.
Yeah, and the change, as for the changes, the last exercise we're going to do today has we've got a database of COVID infection information, and I figured that's a very topical and very real world thing that we can do some SQL queries on. But I wanted us to have the latest information, so I just pulled in the latest stuff last night. So that was why we we couldn't really have that too much ahead of time. But that's our last thing of the day. So our phone book thing, that hasn't really changed. So even if you have the the one from a week ago, there's not going to be any problems with that. Okay, so to get started here, we'll open up this lesson.sql in the phone book directory. And this is actually a SQL file. So you'll notice with the syntax highlighting, I guess the first thing we can notice here is 2 hyphens is how a comment is indicated in SQL. And I have the commands, some of the information, exercises, all those are comments, obviously. And then we have the actual SQL text is syntax highlighted for us. So the first thing we need to do is create this database. So we're going to work through these things here. And again, I think you can see my screen here. So we're going to change directory. We're going to make sure we're in the phone book directory. And I'm going to see if I can make this text a little bit bigger. I'm guessing some people are on smaller screens. This will probably make it easier for them to see. Okay, so in this phone book directory, first command we're going to run is create db phone book. And I'm guessing I still already have it, so it's going to complain. So I'm going to drop mine first, recreate it. And you'll notice quickly scrolling through these, I don't know how much terminal command line stuff you all have done, but things like up arrow and down arrow to go to recent commands. If you don't already do that, that'll definitely save your fingers a lot of work. The next thing we're going to do is we're going to import some sample data. So we're going to run this command psql-f. -f is an argument that says instead of typing some SQL in, we want the psql program to load a file and run it. So we're going to say data context.sql. We tell it which database we want to load it in. And if you run it, you should see that insert 0, 1, or 0, 1. You should see a lot of those. You probably won't see the time. I have mine set up to tell me how long each statement runs. We'll talk about that a little later, but you should see a whole bunch of lines that just say insert 0, 1.
Can you scroll up in your terminal just a little bit so I can see what that command was again?
Yep.
A lot of it's in the README, just FYI.
Yeah, we're working down through the lesson.sql. We're on this thing up here is what we ran. And once we have that data loaded, we're just going to start psql for that database. I'm going to say phone book. And we're going to start with basically about the simplest statement there is. We're going to do a select statement. So we're just going to select name, phone from context. And I'm going to make this a little bigger. Now I have some color shading stuff set up here. It's probably going to look a little different when you run it, but you should see the same data.
And then you have it set up so you don't use capital letters, correct? Jack?
Correct.
Okay.
Yeah, Postgres doesn't care if you use capitals or not. So, if we were to run, it like this, it works the same either way. I got tired of hitting the shift or caps lock key about 10 years ago, so I just stopped.
There's a lot of times Postgres doesn't care. A lot of times you'll see it that way anyway, because it's just a convention to help you understand what are keywords and what aren't keywords. Like in that list above, select and from are SQL keywords, and the other words are parts of the database. But yeah, our style is generally not to do the capitalization.
Right. And this is one of those things where we said SQL is really old. I mean, when it was first coming into being in the 70s, a color screen was kind of a rarity. So the idea of a syntax highlighting text editor, that just wasn't there. So if they wanted to show, oh, this is a keyword versus this is, a table name or something, capitalization was all they could really do. And that's one thing with this industry you'll find there's a whole lot of conventions and names that if you just come in and look at them from a newcomer's perspective, they don't make sense at all. They make sense because they're the solution to a problem somebody had 50 years ago. And we've basically forgotten about their problem. So now we just have the name of, some sort of solution. We don't, even know why we do it anymore. Or when you come in, it looks that way. So a lot of these things, if you see a strange name or something like that, ask us a question. We don't know all of them, but a lot of these, we can tell you where that came from.
How are you getting to show the time that it takes?
Yeah, I guess we can look at that now. There's a timing, I think. Yeah. So if there's a command, if you type \timing, it turns measuring the time off and on. And there's a dot file that you can put in your home directory that psql will read when you start. And it lets you put commands in there to run on startup. So I told mine whenever I start psql, turn the timing on so I can see how long something takes. Okay. So we can select name, we can select phone. There's a shortcut for that. We can just say select star, and that'll select all the columns. So the general syntax, the basic syntax for the select statement is we have the keyword select, then we have a comma separated list of expressions. Then we say, where are these expressions coming from? We say from, and then we have a list of tables. And in this case, we only have one. Now this gives us these 19 rows here. What if we only want a specific row? Like for example, we want to look up, whose name is this phone number? Your phone does something. It might even be this exact code, or if it's not, it's really close to it. Whenever your cell phone gets a number and it tells you who it's from and it's somebody, in your phone book, this is what it's doing. It says, what phone number is coming in? Well, let me look up and see if I know who that person's name is. So you'll notice here that you can type multiple lines and it's not running anything yet. It won't actually run a command until you have the semicolon. That is what tells it that is what is the terminator for a SQL statement. And SQL statements tend to get long enough that I typically will break up each clause of the statement or each phrase onto its own line. But splitting onto lines or not splitting onto lines, the database doesn't care about that. That's just for us. Okay, so with that in mind, let's do an exercise here. We can, let me explain a little bit more about where. The where clause is a Boolean expression. It's going to look through each one of these tables or each one of these rows in the table, and it's going to say, does the phone number equal this thing? It goes to this one and it says, nope, nope, no, 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 no. And eventually it gets down to this one. And it says, oh, that one is true. And every one that is false, every row that is false, it discards. Every row that is true, it includes. So that's why we went from 19 rows down to 1 row. And the where clause, it's a Boolean expression. So whatever you do must evaluate to true or false. Well, one of the comparisons we can do, and I'm sure you've run into this in Python already, is you can just test for equality. Now, the difference in SQL is you use a single equal sign. I'm sure you've run into that in Python. That's like, oh, 1 equal sign is assignment, 2 equal signs is, test for equality. Well, in SQL, it's just 1 equal sign, and 1 equal sign tests for equality. So let's see if we can do a couple exercises here. And I'll give you about 2 minutes for this. You can ask questions if you want, either just talking or you can message me or Jake or the room. Also, I'll mention for all these exercises, there is a solutions file. I recommend trying to figure it out on your own first, but especially if you're reviewing this, tomorrow or later out in your course, there's the solutions for all the exercises as well. So I'll give you about 2 minutes here. Try and work our way through these 2 exercises, then we'll discuss them further.
Just got nothing but errors in the beginning. I'm not sure why.
Okay. What in pSQL or before pSQL even starts?
I'm sorry. I thought I had my I thought I had my finger on the microphone. I was able to create the data book, but I was having trouble importing
Okay, so usually, I say usually, Jake and I have been doing this workshop enough times that most problems we've seen a bunch of times. Usually that problem is running that command in the wrong directory.
Mm,
So if you look at my screen here, you see that I'm in that phone book directory, because the path to that file you're loading is a relative path. So if you're in the wrong directory, it's not going to find it.
okay. Let me try that again then, I guess.
Yeah, we have these terminal prompts that show our directory, which is definitely something you want, I think. If you take some time to tune up your terminal, definitely add that. But you can just do pwd enter, and that will show you where you are.
Right. And for an example there of like, what does this arcane word or acronym mean? PWD stands for print working directory.
Is that where is it showing that you are when you run that command?
So it was just saying that, what was it? Trying to find it right now. So I created the phone book, and then when I tried to import the sample data, it gave me an error. And then this says the relationship doesn't exist. Let's see.
I think I might know what your issue is. Do you have another database in that same directory that has like the relation contacts, like any of your previous projects?
No.
Are you
I just,
sure?
yeah, I just forked this morning and I just pulled it up as its own file.
Because it could be potentially trying to like insert into that, and if that already exists, it might cause a conflict.
Maybe. But this is just the instructors repository. I just forked it and copied it and pulled up the SQL workshop. I don't think so.
If you type in PSQL and then type in /L, and then if you look through each of those directories, see if potentially you might have a contacts relation in there.
I'll check. He said /L.
Mm-hmm.
Okay.
Jose, are you trying to run the import command from inside of your database? Like, are you already inside of PSQL?
No, I'm just following literally how it's structured in the README.
Okay.
Yeah.
So what happens when you run that? Well, first of all, before you run that psql-f command, what is the print working directory?
Give me 1 second. I'm getting too many questions right now. So yeah, no. Let me just run it really quick again. So I'm gonna go ahead and I'm gonna put PSQL -f /.
So what happens when you type just pwd in your terminal?
Let's see. Says lecture code SQL workshop. That's it. Keyword PWD. It's up.
Yeah. So are you inside the phone book directory?
Let's see. I'll put ls. Don't think so. No.
Okay. So you have to cd into the phone book directory.
Okay. Maybe that's why. Yeah.
Yeah.
That's probably why then. Thank you, gentlemen.
Cool. Okay, so for these exercises, when we want to look up a phone number, we say where name equals such and such. And where we want to look up by phone number, we say where phone number equals such and such. Now you'll notice that both of those things are surrounded by single quotes. In SQL, in Python, I think, and I know like in JavaScript and Ruby, you can use either double quotes or single quotes more or less interchangeably. There may be some subtle differences depending on the language, but for just a simple string, you can use whichever one you prefer. That's not the case in SQL. In SQL, a single quote means this is a literal bit of text, it's quoted text. And double quote means this is an identifier, as in this is the name of a table, this is the name of a column. So in this class anyway, we're probably never going to use double quotes, but you will get some weird error messages if you accidentally do use a double quote. It'll say something like, no such column or no such relation. All right, so do we have any questions on these exercises? Okay, I'll take that as a no. All right, move along here.
I'm sorry, I couldn't find my unmute button. Are we moving down through all of the exercises ourselves, or are you going with us?
So we're going through them like section by section.
Okay.
So so we did exercise 1.1 and 1.2, but that's as far as we were planning on going right there. So I'll be going with you on from them. Okay.
If we got an unexpected result, should we be checking with you now, or are we going to get to the end and then kind of ask questions?
Yeah, you can ask now. So what happened?
I just did the select all from contacts where name equals Lori Abishire, and I got 2 rows with her name in it versus just 1.
Ah, okay. So what I'm guessing happened there is, by chance, did you run that initial statement with the -f that loaded the file? Perchance, did you run that twice?
Yeah. Ooh, potentially, yeah.
So yeah, probably you've got like 2 copies of everything.
Got it. I'll run it, or I'll clear it and run it again. Thanks.
Yep. Okay, so what happens if we only know someone's first name? So there's another comparison operator, and it's called like. And what that does is it lets us match patterns, simple patterns, instead of exact text. So in this case, we're going to say, find the name and phone number from contacts where the name is like Tammy, and we're going to put a % thing there because that is the command character, I guess you'd say, that matches a pattern instead of actually matching the literal letter. Oh, so if you see something like this, you probably did the same thing I did, where I connected to the wrong database. So there we go. So we can use the % character anywhere in our text, and it'll say, okay, when I run into this, then match any number of any character. And the position that the % lives in is where that match will occur. So for our next exercise, we're going to just look for someone with the last name of Herman, and we're going to do the same type thing we did here, only we're going to have something else in the name here. So I'll give you a few seconds there. And we basically just move around, where does the percent sign go? And now we just ask, okay, find, where the name is like any number of characters followed by Herman. And this gives us, Samantha Herman. Now, what would happen if I didn't capitalize it here? We get nothing back. So the like comparison operator is case sensitive. Well, for matching text, lots of times we really don't want that. So the I like operator is how we can search case insensitively.
Hey, Jack, I mentioned tab completion before. Would you mind demonstrating that?
Yeah, sure. So I'll just do it right here. So when I say from, I'm going to type CO. I hit tab, and it completed it. So pSQL, it has fairly good tab completion. If it knows this is a place a table should be, or this is a place a column should be, or maybe even this is a keyword, maybe, no. You can hit tab a time or two, and it will try to autocomplete. Like it could complete name there. It doesn't, it only can complete if it has enough context. So like it's pretty good at completing table names, and it can complete column names if it already knows which tables are available. Otherwise, it would have to look at all of them. But it does tab complete works some of the time, we'll say.
Yep, I mentioned this earlier, but just to reiterate that if you're in a terminal or a read, evaluate, print loop like this, IRB or Python or pSQL or MySQL, they all have some version of this feature, and it's just an incredibly good habit to get into because it saves you keystrokes, thousands of millions of keystrokes over your life, right? If all you do is type SE tab instead of all of select, that's shorter. But it also it saves you a lot of typos because it completes it for you. So just a pro tip for the command line.
Yep. Another thing is Control R is reverse search. So like if I were to search, see how it's based on what I type, it's choosing which let's get into real work.
Yep. Thanks, Jack.
Yep. Yeah, up arrow, down arrow, Command R. So that's the very, very basics of how we select some data. Well, we don't just need to select data, we also need to insert data. So the insert statement is the command that, inserts stuff. So the syntax is we say insert into, then we say which table we're going to insert into. Then we supply a list of the columns that we are going to include. Because you don't have to include all columns if there's like a default value or something. So we'll say we're going to supply the name and the phone. Then we use the keyword again, values. And then we say, okay, what is the name? And what is the phone number? And we remember we have to end this with a semicolon. And if it worked, it should say insert 01. Now that message that comes back, you know, it'll usually say insert, or it'll say update or delete or something. That is the database telling you this is what I did. The two numbers there, the 0 is irrelevant. It's a obsolete thing that they used to actually send back a certain bit of information there, but it's not meaningful anymore. To avoid breaking old programs that rely on there being a number there, they always include a 0 there just as a placeholder. The 1, on the other hand, is meaningful. That says how many rows did I insert. There are certain commands, certain ways of using this command that you can insert multiple rows at once. And it is nice enough to tell us, oh, you inserted 12 rows, or you inserted 1 row. So we just inserted this row, and we can see that it's there if we do select star from contacts. And sure enough, there on the bottom, there's our John Smith. So let's see what happens if we insert a row without a phone number. Okay, now we're getting somewhere. So Jake mentioned this a little bit in his initial lecture. What null is. So if we use \d, here's another one for you. \d is for like describe, and you can say \d and tell Postgres the name of a table, and it'll show you some information about it. So in this case, our contacts table has a name column and it has a phone column. They both are the type character varying. And again, Jake mentioned a bit about this before, but you can think of type in the mathematical sense as like, what is the set of allowed values? You know, in this one, it's all possible textual data. But like for an integer, it's, you know, all possible, you know, all integers between, you know, all 32-bit integers to be precise. So between roughly -2 billion and +2 billion. And that helps us by making sure we don't put, you know, a number into a text field, or text into a number, or a number into a date. The null ability, we'll get more into this later, but one meaning of null is empty. So by saying this is not null, we are saying that for a contact record to be valid, it must have a name and it must have a phone number. So when we tried to insert something that did not have a phone number, it didn't let us. It gave us an error. If we look at all the contacts again, it's not there. So not null is a great way of helping us catch our own mistakes. It's kind of like building guardrails for yourself. It's easy to put bugs in programs. So any way that we can put up some guardrails and say, okay, if I or somebody else makes a mistake here, stop me, those are good. All right, we already talked about this stuff here, \d, looking at a table definition. We talked about null, one meaning of it is empty. Now let's talk about updating a record. So we're going to run this command. We're going to say update contacts. Set phone equals this number. And we get that response back from the database. It tells us how many how many rows did we update? We updated 1 row. Let's talk about the structure of the update statement. So an update statement starts with the keyword update. And then the next thing is we have to tell it what table are we updating. Then we pass it in the set clause. We give it a list of, basically key value pairs. We say this column equals this value. And we can have more than one of them if we want. We could say, we could change their name if we wanted. And it's a comma separated list. Then finally, we have a where clause. We have to tell it which rows we want to update. And just like the select statement only returns rows where the where clause evaluates to true, the update statement works the same way. It only updates rows where the where clause evaluates to true. So like if we were to change this here to something else, well, the statement was actually entirely successful. It was syntactically correct, it ran, but it just didn't update anything. All right, so let's do a quick exercise here. We're just going to change John Smith's phone number. And if anybody has any questions on, insert or update, this would be a great time for questions too. We'll have about 2 minutes to work through this little exercise.
Question, Jack.
Mm-hmm.
If we use the, let's say we're trying to update the number and we use the like, and we use like Johnson, will it update everybody's last name with Johnson?
So if you used like, well, I guess the first part of it is for every row that Boolean expression evaluates to true, it'll update. So I don't know if we have more than one, Johnson or not there. I don't think so.
No, we don't. I was just asking if, that would be a danger, because then like it would only update the first instance or just all of them.
Oh, it'll update all of them where the clause matches.
Okay, thank you.
Yeah, in fact, as far as it being dangerous, if we were to omit the where clause altogether, it would just update all the rows. So that's definitely something to avoid.
Question, what if you actually did that on accident?
Well, if you did that on production, you're going to have a really bad day.
What if we did that today?
If we did that today. Okay, the simplest thing there would probably be to get out of P-School, which actually we haven't talked about that yet. So to exit P-School, you can do a \Q. And that's how you quit. So what I would do in that case would be to drop the database. Just like you have create DB, you have drop DB. So I would drop DB, phone book, and then run through, up to this point, create DB, run the P-School F, whatnot.
Yeah, I think that's alludes to something that I always end up mentioning at some point when we teach this this day, is that so there's like there's a disconnect between what we're doing here and what you do for your job as a programmer, right? Like if you want to update a record on the production database as a programmer, you would not connect to the production database and type out a SQL command and hit enter. You just would never do that unless the world's on fire. It's just it's a really bad idea. But we're doing that now, so I can understand why a question like that might come up. Like, what would have happened if you were to type something like this and you were to change the data and really mess it up? The answer is that you just don't do that. So we can talk a bit about how you practically change data on a production database, because there's a process to it that's very predictable and boring and not scary at all. But the short answer is
still a little scary, but
yeah. Do you mind if I talk about this for a sec, Jack? Or
go for it.
Yeah. So when you're actually running a production database, right? The way that this works is you have a development environment, and then you have a staging or QA environment, and then you have a production environment. So if you want to change the shape of the database, you write a script called a migration, And the migration changes the shape of the database. We haven't even gotten to that yet, but we will soon. It changes like the table structure for you. And it can run backwards and forwards. So it will, it'll change the database. And then if you run it in reverse, it'll change it back. The Jack's showing us one written in SQL, and is this a, yeah, so this is a migration. It's an alter table command. So he's altering the table IC types, adding a column called intil, that's a Boolean, and adding a comment. So a migration like this, you'll write it in a file. And do you have one, Jack, that has a down as well, or do these just understand the down?
Yeah, I don't have a down. To be honest, I've kind of moved away from ever writing down migrations because I just don't worry about down migrations anymore.
Sure. Well, a down migration is like the reverse of this. So typically you'll write if you're being very uptight, you'll write a version of this in reverse. So you alter the table and you drop the column. And then what you do is you run this command on your local database, you run it forward and you watch it change the table, and then you run it backwards and you watch it change the table back, and then you run it forward again. And then every time you change the database, you do that process. If you want to change data, you usually write a script too. So you might write a task, or sometimes in a migration, you can change data. You can write that statement in the up method if you want, and in the down, you can change it back. So on your local database where there's no risk of anything, you just run it, you run those things. And then when that succeeds, then you would deploy that to your staging environment where the database is, exactly like production, as close as possible to production. And you'd run it there and you'd watch it succeed, and you'd check and you'd QA test and you'd feel good about it. And then after all that's happened, you deploy that same script to production, run it against an identical database to staging, and it's still not a system that never goes wrong. Like it can go wrong, but it's very, very predictable most of the time. And if you're worried, you can back up the database before you run it. So if your migration fails in some awful way, you could just restore the backup. So this today, when we're like typing in the SQL, in P-SQL, is a really amazing way to learn. And it's like, you're going to do this all the time. I mean, every day I type something into a Postgres REPL to look at data in a local database and figure out what's going on. So the skills are very practical, but the specific thing we're doing where you're like changing stuff on a table, you don't do that in production if you can help it, because it's really, it's
really dangerous.
It's really dangerous, and you're going to be sad if you try to go that route. So even when you're in an emergency situation, your best bet is to try to do the process that I talked about. If you'll get fast at it to a point where it's not a big deal to do that. You can go through that process in like 10 minutes, and you'll save yourself a lot of sadness.
Yeah, we'll do this type stuff in development. Like Jake was saying, I'm in P-SQL all the time, and like I'll use it to iterate on, okay, what change do I want to make? Then you put that in a migration, and then you run it through the full, through the full process. But yeah, the way I like to think about it is if you're directly doing stuff on production through the SQL prompt, basically it means you've already had a bad day, and if you're not real careful, it's going to get a lot worse. Okay, so our next thing here, as an example of one of the things that can get really worse, really bad, or really quickly, is if you forget a where clause on, for example, deleting a record. So let's delete something here, and we'll definitely want to include the where clause. And the result it gives us, again, it tells us what it did and how many rows it did it to. So luckily that did only delete 1 row. If you do this and you see delete 20, sorry. All right, and yeah, the little notes here, select, update, delete, they all allow a where clause. And it's really, really important when you're doing this on a delete or update statement. And I'll tell you another place where it's really important that we do know to do this. If you were writing like application code and you had to write a SQL statement in your application, this can also be dangerous there where, okay, in development, I only have, 1 record and I wrote my code to delete that record. It works. Let me deploy it to production. Well, it worked in that you only had 1 record and it did delete 1 record, but you didn't tell it which record. You told it delete all records. And it seemed to work because you didn't have any way to notice the collateral damage. So this is something not just for when you're doing a migration. If you're writing a SQL update or delete statement, sometimes even with an ORM, like even in with Ruby on Rails and whatnot, you can write a statement that doesn't include any conditions, like, oh, I guess you just want me to delete everything, and it'll happily do it. All right, so what do we got next here? We've got ordering. So this is something interesting here. Let's do a select star from context again. And if we look at the order of these rows that come out, one, if you all run it, somebody may actually have this come out in a different order. Probably not, but it's possible. The second thing to notice is the bottom 2 rows. So John Smith is toward the bottom. That was, we inserted that record, and then Simone's record is that's the one we just updated. So one of the things that a database system gives us is it handles the nitty-gritty details of where on the disk, the storage device, does this data actually live? And that's a harder problem than you might think at first. I don't know, if y'all are old enough to remember like the school printers where you print something out and like all the pages were connected, or maybe you've seen that like on an old TV show or something like that. But imagine that where you have, just some, 100 feet of paper and you want to change something in the middle of that. On page 55, you need to delete a line and add 4 lines. How do you do that? I mean, think about that like physically for a second, how would you do that?
Scissors.
Scissors, yeah, exactly. But yeah, it'd be a mess. And we don't really have the option to do that. Well, let's say, let's make the analogy a little closer. So we can't use scissors. All we have is a pen, or we have a pencil and we have an eraser. How are we going to deal with, we want to remove 1 row on page 55 or 1 line of text, and we need to insert 3 lines of text there.
You're going to line through the one that you want to delete and say, see this section for the 3 new rows.
Yeah, actually, that's a great idea. And that's actually a little closer to what the database actually does. The naive approach, there's 2 naive approaches. One would be, well, let's get another 100 sheets of paper and let's make a copy of this and make the change along the way. That another approach would be, we'll delete, we'll erase everything from page 55 on. We're going to erase everything and we're going to rewrite it all so we have room for those 3 rows. But obviously that would be really, really inefficient if you have very many pages, very many lines. So you're actually right about what if it just made an annotation that said it's no longer here. And at the low level, the way Postgres actually works is if we were to do that, it'll mark that line on page 55 and it'll say, this has been deleted. It'll write a line, it'll draw a line through it. it doesn't actually record where it should go next, but where it actually does write it is it goes to that page, finds some blank spot, on page 100 or whatever, and it adds, it writes the row there. So internally, it does a lot of like bookkeeping of, it actually has things called pages that are a fixed size, and each page has so many rows on it, depending on how big the rows are. And it has indexes to keep track of, which rows are on which pages. And if you delete something from one row or you update it and it's now bigger, it has to go onto a different page. And there's a whole mess of things like that, which fortunately we don't need to think about in our day-to-day work. That's part of the advantage of a relational database, is it handles all that for us. But why I was going down that trail is it does leak out occasionally. So we inserted that row, John Smith. Well, it's now the last thing in that, file essentially on the disk somewhere. And when we did that update of Simone's record, the way Postgres actually does an update is it marks the previous one as deleted, and it essentially inserts a new one, in this case, at the end. So what that means is the order these records comes back is undefined. Based on, which order we inserted stuff in. It can even be if two people are using the system at once, that may affect which order things come back. But the end game is you can't rely on it. It's completely undefined what order stuff will happen in. If we care about the order, we have to specifically specify what order we want. We do that with the order by clause. So order by takes a list of expressions by which it should order. And in this case, our expression is just name, it's a column identifier. And we only have one of them, so we don't need to say, this comma that or whatever. It also has a default order. The default order is ascending, and based on, if we figure A is the lowest one and Z is the highest one, it goes A to Z. And we can reverse the order by saying descending. We can explicitly say ascending if we want, but since it's the default value, we rarely do. So that's pretty simple so far. Right? Well, I say it's pretty simple. I got to be careful saying that. Sometimes, things are simpler after you've seen them for 20 years and you forget how crazy they are the first time you see them.
So in this circumstance, there wouldn't be any way to check by last name, right?
Correct. That's very correct. So that'll bring up something that we'll get to sometime today. This context list is purposely wrong. There's a few things wrong with it. One of them is we shouldn't be storing the name as, the first name and the last name together. At least if we want to sort by last name ever. So yes, that is something that we do not have a good way of sorting by last name right now.
If I wanted to add an ID and I wanted it to go alphabetically, would I have to do, is that possible? Would it just be like select everything from contacts, order by name, and then do the alter table and add column ID, or is that not something you can do?
So to technically answer the question exactly as you asked it, yes, you can do that, but you wouldn't want to, is the thing. So generally speaking, your IDs will be like meaningless numbers, and you really don't want, well, there's a little bit of a debate in the database community between whether you use what's called a natural key, as in this key is something that's intrinsic in the data and it has meaning, or a surrogate key, which is generally an ID like an integer or a UUID that has no meaning at all. It's just an arbitrary identifier. You're going to be, I believe Tom mentioned you're going to be using Django ORM eventually. And most ORMs, I would say not all, but many ORMs basically insist you use a surrogate ID. So you just have a single column that's an ID value. And most of the time it's going to be an integer, at least when you're starting out, that's the simplest thing. So yes, we could insert an integer ID and we could order it. So 1 is Archie and 2 is Bilia and 3 is Cassandra and 4 is Chang, so on. But the problem is what happens when we make a new friend and, now, we have a new friend, Alice, and she's going to be ID number 23. Our order is going to be entirely broken. So yeah.
Got it. Thank you.
Yep.
Are you talking about for the natural key, kind of like a social security number would be a unique number and therefore could be used as the primary key?
Yes, kind of. As in, that's what people oftentimes did do before they realized, oh, this is a big privacy issue. We need to hide SSNs. So that's a great example of what people would think of as a natural key. It's also a great example of the risks of using natural keys. So the two problems, like one of the first projects I did when I started working professionally actually was working with a very old system, pre-SQL actually, that did use SSNs as a primary key. But there's one obvious problem with that now and one not so obvious problem. The obvious problem is the privacy concerns nowadays. 30, 40 years ago when they were building that system, they didn't really think about those problems. And now we do. The other problem is SSNs are not actually unique. They can be reused over time. And it's rare, but like in cases of identity theft or something, it is possible to get your SSN changed. So if you have that as the fundamental identifier of a person and then it needs to be changed. So yes, that is an example of it, but that is an example that would be a anti-pattern nowadays. I'm trying to think what would be a good example of a natural key nowadays. Maybe that's why most people use surrogate keys. It actually is hard to think of. Well, I'll tell you actually where I tend to use it a little bit maybe. This is also the idea of a composite key. So if you have, say, a list of people and you have a list of jobs and you have, or like roles or positions, and you keep track of when, of somebody's assignment to that role. It might be fair to say the natural key there is the person's ID and the role or job's ID. The combination of those should be unique, perhaps with a time range, depending. It's a slightly contrived example there. But that's where I have used natural-esque keys, where it's like a combination of keys when it's a join table.
That's actually an example of something I did for a scheduling database. Because somebody's role was time bound. And so the combination of all of the different things, that was the the natural key, not the surrogate key.
Yeah. Yeah, that's a good example. Yeah, anything that involves like reservations as well. In fact, I don't know, occasionally in our afternoon session, we've done a data modeling thing and we've done like the hotel industry. And you might end up with something there where, you have rooms and you have customers, and a natural key for a reservation is the customer, the room, and the date range that it's being reserved for example.
I mean, couldn't we use just like the last 4 of a social as a natural key, or?
Well,
It's not as revealing, so.
well, the problem there is a key must be unique. So there would be collisions between, within a group of a few thousand people, you're going to have a handful of collisions.
Hey, Jack, let me know when you think we should take like a 5-minute break.
Oh yeah, that's we'll look at limit, and then that'll actually be a great time. So we'll break in about a minute. Thanks for reminding me that. I slipped my mind. So the next thing that goes along with ordering is limiting, where we can say, only give me back 5 rows. And in this example here, so I'll just copy and paste this for time's sake. We're saying, give me the first 5 rows sorted alphabetically. And you run into this type thing, if you have like scoring or something, give me the person who scored the highest on this test, or give me the 10 people who scored highest, or, find me the people who scored lowest, or anything like that, where you're trying to find, what is the best, what is the worst, what is the highest, what is the lowest. Ordering by something and limiting is the simple way to answer those questions. All right, any quick questions?
Is there a default limit that we'll get back? Like if our database is hundreds of thousands of lines long, will it display all of them if we don't put a limit on it?
Yep, it'll display all of them.
Okay.
Yeah, that's another one that can be dangerous if you do this in production. Like it's a little more common and still not necessarily a good idea, but it's a little more common to connect to production to run reports. And if you write a select statement that basically infinite loops, you can basically DOS or denial of service your own production system by running a bad report.
One other question, as far as if we were to sort by the phone number, what would it be looking at? As in just the first digit, or would it be looking at the first 3 digits or all of the digits?
Would look at all of it. But it'll sort it textually. It doesn't convert it to a number. So like if we had I know phone numbers don't start with zeros, but if we had a, all zeros or something like that, it is sorted lexically, would be the fancy word for it, but it's sorted basically alphabetized. It's not converting it to an integer.
Got it. Thank you.
Mm-hmm. Well, let's come back at 11:20. That'll give us a 6-minute break, and then we will start talking about keys a little more and primary keys and how to tell rows apart. All right, well, let's get started again. So now we kind of already talked a little bit about keys, but now we're getting to the point in the lesson where we want to dive into it in a little more detail. So this table that we have really has a big flaw in that it does not have a good way to tell people apart. You know, there are many people who share the same name. Back before cell phones, many people shared the same phone number. So if we were going to say, oh, well, the name is a primary key, well, you better hope you don't end up meeting two people named, you know, John Smith. If you're going to say the phone number, well, you better hope that you don't know two people in the same household. So we need some way to uniquely identify rows. And in SQL or relational database terminology, a unique identifier is called a key. And you'll hear most often with this, you'll hear the term like primary key. That's the most important unique identifier. And with very, very few exceptions, in fact, some people would even say no exceptions, every table should have a primary key. So let's add one to our table here. Now, we are going to use this command here. And this is the stuff that we've learned so far, like select, update, you know, insert and delete. That's stuff that you're going to want to learn, and probably you'll learn it just by using it enough. These alter table commands, those are things you don't use every day. So for years, whenever I would need to do this, pretty much I would have to look at the docs every time. So I don't really expect anybody to say, oh, I better memorize all the syntax for how do I, you know, add a column, give it a identity, you know, generated by default as identity, you know, that's how you tell it, you know, start at 1, then 2, and then 3, you know, how you make it auto increment, and then add the constraint of a primary key. I don't expect anybody to actually remember that until you've done it a bunch of times. So this is stuff that you should use the documentation for. And the Postgres documentation is really, really good. And it's worth learning your way around. But beyond even that, you know, this is the type thing that you would find very easily on Google by just searching for like Postgres add column, you know, or Postgres add primary key or something like that. And you would find the answers fairly quick there. Let's run it here. So we added a column, but I guess to offer the brief explanation of what this syntax is, you know, alter table is the command. We have to tell it what table do we want to alter? Well, we want to alter the context table. Then this command takes a list of changes to make. So we're actually making two changes. They're separated by a comma here. The first one is we're saying add a column. Then we supply what name do we want for the column. Then we say what type is the column, saying it's integer. This long mess generated by default as identity, that's just kind of one of the magic phrases to learn at this point. You can think of it that way anyway. And that's what does the auto increment. You may see in some documentation where instead it'll say something like this. And that still works. And that's a Postgres specific thing. This style here was added in Postgres within the last several releases. And this is the SQL standard that should work on multiple databases. That's another nice thing about SQL is SQL is a standard language. And though there are minor variations in dialect, the core language and definitely the way you think about it, you could take what you learned here, you could use it on Postgres, you could use it on MySQL, you could use it on Microsoft SQL Server, you could use it on IBM's DB2, you could use it on Oracle's database. And the core SQL language works everywhere. You could also use it on SQLite or SQLite. which is actually another really cool database, and many more beyond that. Okay, so we added a primary key. Let's look at this table now. So now we have an ID column at the end and we have a number. So now if we want to refer to a particular row, we can just refer to it by number. And that's really convenient for the ORMs because most of those, like I said, rely on you having a surrogate key and it's a single column key. Now let's start getting to where relational databases put tables together. So we have contacts, and your phone book on your cell phone, you have your list of contacts, but it also keeps track of when you talk to them. So this is one of those, again, let's just copy and paste this. We created a table. The create table command, again, is one you'll need to look up for sure for a long time. You tell it what is the name of this table. Then you give it a list of columns, and it's the name of the column, then the type of the column. Then there's a handful of optional things you can say. You can say this is not null, or you can say this is a primary key, or you can give it a default value through this generated by default, or you can also do default things here as well. Various expressions, but there's a bunch of different options there, but this is the core of it. And like I said, the documentation is, you'll really have to refer to the reference material most of the time. There's a couple interesting things here that I think are fun to talk about. So there's two new types. We have timestamp TZ, which is short for timestamp with time zone. And we have interval, which is an interval of time. So there's a couple interesting things to discuss here. This affects databases in SQL, which is why we're talking about it here. But most of this also applies to anything you do in programming. So let's start with a little discussion here. So like, what is a time? Like, what do we even mean by that when we say, what time is it?
Time is a contrived concept that is a distance measured in moments from a particular time-ish.
Yeah, kind of circular, but yeah, I mean, I suppose if you really want to get into what is time, then now we're into philosophy or something. But, if we say, I look at my clock here and I see it's 11:28 a.m. But I'm guessing since not everybody is in the central time zone, when you all look at your clocks, some of you see a different time. Yet it's the same time for us, isn't it? So when we say what time did an event occur, for example, that's usually what we're thinking of it in database speak. We're trying to record or predict, when did some event happen? When will an event happen? So just saying it's, how do we specify an exact moment? So that kind of leads into, fairly obvious answer to this next question. Do times include time zones? Well, I mean, they should anyway. Sometimes they don't. But if you want to actually know when did this happen and you don't have a time zone, you really don't know when it happened. For a little more subtlety, does a date include a time zone? If we say it's, February 23rd, what does February 23rd actually mean?
It's just the day, but it doesn't tell you what time of day.
Right. It's just the day. If we think of it in terms of times, though, I would see it as the time range between, February 23rd at midnight until, February 24th at midnight. You could see it as a time range. Well, if it's a time range, then we're back to that question, in which time zone? So time zones come into play a lot of places. If you're writing a program for one business at a specific locality and they never, expand or anything, you can kind of get away with ignoring it a bit. But in today's world, that's not so likely. You're building software for the internet, questions of like, when did this happen? If a bill is due, or, okay, somebody has a subscription and their subscription ends at the end of the month. Okay, at the end of the month, in which time zone? You end up with a bunch of like interesting questions like that. And it boils down to time and date are essentially meaningless without also knowing the location. And generally we encode the location as the time zone. Here's another fun one. Can time go backwards?
It depends on what time zone you're coming from.
Exactly. It can go backwards. In fact, within the last 6 months, most people here have experienced time going backwards. The fall time change. We went back an hour in time. In another month or so, we're going to skip an hour in time. I guess that's kind of that's actually a little bit of the answer to our next discussion thing. Do all times exist?
Well, I hate Benjamin Franklin.
Yeah, yes. Yeah, you speak for all computer programmers. Yeah, so there are times like 2:30 a.m. I don't know, is it April, whatever? I don't know what the time zone is or what the time change date is this year. But 2:30 a.m. someday in the next month will not exist, at least in my time zone. And 6 months ago or whatever, when we went back in time, it was at 1:30 a.m. existed twice. So if you don't have the time zone thing, and that's even more important than just saying the locality. If you don't have the time zone, you don't even know, okay, it's 1:30, which one is it? The first one or the second one? So time zones are a real mess, a messy problem. Do all dates and times exist? That gets even more fun than, okay, we skipped an hour. How about, are there some days that just don't exist entirely?
Leap year?
Sure, leap year, leap seconds.
Yeah. So February 29th only exists, 1 out of 4 roughly years. There's some exceptions there. We're like that every 100 years and every 400 years, the rules are a little different and all that sort of mess. But even more than that, with any historical times, you've got the whole like Gregorian calendar thing. So you have like a couple weeks that don't exist in our calendar system because they were correcting for, centuries or millennia of not having leap years, essentially. And then because that was organized by the Pope and not everybody was real fond of the Pope right then, the calendar change happened at different times in different countries. So if you look at some date, for hundreds of years, different countries kept different date systems, So you don't really have to worry about that much after you get past, I think it was like 1900 or so when probably the last people gave in. But there's all sorts of craziness there. And the short of what that means for us in Postgres is going to be, we always want to use what's called timestamp with time zone, or the shorthand for that is timestamp TZ. It's very, very, very rare you ever have a good reason not to include, not to use that timestamp type, or with time zone. But the other more general thing here is times and dates are really, 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 really hard and really, really, really complicated. And unless you're actually like building the standard library for a new operating system or something like that, or new programming language, you should never do anything by hand. You should always find a library that'll do it for you. Because even like basic assumptions, like I wrote a time clock system at one point, And I ran into a bug where, oh, wait a minute, I thought days were 24 hours. Well, no, once a year they're 23 hours and once a year they're 25 hours. So I made the mistake of just saying, well, add 24 hours or subtract 24 hours. I don't remember what the details were now. But then the day after time zone, people's clocking in and out was wrong. And I had to go back and, fix that. Fortunately with Postgres, Postgres basically handles all this stuff for us, or it can if we ask it to nicely. Confusingly, so the short thing of this is always use the built-in standard libraries. There usually are specific calendar functions. I mean, even that is messy. If you say 3 months from now, how long is 3 months in days?
That depends.
Depends on the month.
Exactly. It depends on where are we starting from. So, and people might say, okay, we're just going to say months are always 30 days. You can do that. But if you actually care, or like, what does it mean if we say, it's January 31st and we say, what is a month from now? There is no February 31st. So do we say it's the 1st of March? Do we say, anyway, those are all really messy and you really don't want to have to deal with them yourself. So fortunately, Postgres has a very robust date and time system that can account for those things. And in particular, the shorthand of this is you actually want to use timestamp TZ, which stands for timestamp with time zone. Now, unfortunately, I would expect that if I saw a data type called timestamp with time zone, I think you would forgive me if I expected it to actually have a time zone. But
That'd
it
be
doesn't.
nice.
Yeah. So what Postgres actually does is it always converts time with its timestamp with time zone type. What it really does is it always converts it to UTC. And it converts it on the way in and it converts it back on the way out. So when you're talking to Postgres, you tell it, I'm in such and such time zone, and it'll automatically translate stuff as it goes in and out, which can be convenient, but it's also a little confusing if you actually care, like if you're doing an appointment book or, a calendar type thing where you say, this meeting is in San Diego at 11 a.m. and you actually care, I want to remember that this is in this time zone. It doesn't do that for you. What it really means is, convert to UTC on the way in and convert back on the way out. Okay, so with that bit of a digression, times, dates, time zones, they're all terrible. Use the library's built-in features. Okay, so let's insert a call record. So I guess this actually brings up that interval thing. We talked about how long is a month. Well, Postgres interval type is designed to handle those things. So it is a type specifically for lengths of time. And it has this really friendly syntax where we can actually just type in, 3 minutes and 23 seconds, or we can just say, 3:23 or, various options of that. All right, so we inserted a record here. Let's look at this record. We'll do select star from calls. All right, so we inserted that record. It generated the ID of 1, and we told it the contact ID. So we're actually referring back to our contacts table. So we were saying this is a call from Miranda Carroll. And the call lasted 3 minutes and 23 seconds. So there's also a clause on the insert thing called returning. So sometimes it's really useful to know, okay, I inserted a row, but what ID did you assign for it? If we're using surrogate keys, generally the database is assigning the ID. And it'd be nice to know what it was. So we can say returning ID, and this gives us back, the returning clause actually is basically turns it into a select. So we could say returning ID, comma, this, comma, that. We could say returning star, but usually we only care about the ID. Now here's the thing. Remember we talked about earlier when we insert rows that we can insert multiple rows at once? Well, this is how. The values clause can take multiple, comma separated row values. So we'll do this. And it just inserted 2 rows. So we can see that that returning ID, it gave us 2 results here. And the insert result tag here, command tag is actually what the Postgres internals call it, says 2. We inserted 2 rows. Okay, we kind of been running through that a little bit. Any questions there? No? Okay. Well, let's find out. What would happen if we inserted a record, a call record for a contact that doesn't exist? So we do not have a contact ID 9999. But we're going to say we talked to him for an hour. Oh. Well, that's interesting. We just inserted some invalid data. So let's clean that up by deleting that ID here. So on my computer, this is going to be ID number 5. If you've been experimenting a little bit on your own, that may have been a different ID there. So whatever it showed you for that last returning ID, replace that, and we'll delete this. So Postgres can solve this problem. And how you do that is something called a foreign key constraint. So let's talk about what all those words mean again. So we already talked about what a key is. A key is a unique identifier. Well, a foreign key, that's saying we're storing the unique identifier for a row in a different table, a foreign table. So on our calls table, contact ID is a foreign key. It's the ID for the contacts table. The constraint part is, it was a foreign key regardless of if we specified this or not. But the constraint part is make sure it always is valid. So we're going to say the foreign key contact ID references the contacts table. And in particular, it's referring to the ID column. So we're going to run this. Tells us, yes, I altered the table. Now let's try this command again. And it stops us. It's not going to let us insert a call to a contact that is not existent. And it tells us there, it might be a little hard to understand this the first time you read these error messages, but it's fairly detailed anyway. Tells us that we were trying to insert or update on the calls table, and this particular constraint failed. And the constraint that failed was these values. So we almost always want to use a foreign key constraint. Again, that's a thing where there are a few occasional exceptions, but they're very rare. And in practice, you can just think of it as a rule. If you have a relationship between tables like that, you should add the foreign key constraint.
Question, Jack. Is there, other than trying to insert something that we know is not valid, is there a way to know if our table already has, or someone already set up a foreign key constraint?
Yes. So that \d command will tell us what foreign key constraints are there. So they didn't show up before because we didn't have any, but \d does tell us that.
Okay, thank you.
All right, so now we get to what really makes relational databases powerful. Most of what we've done previously, one way or another, you could kind of do with a spreadsheet. You can kind of think of a spreadsheet as a single table. So, most everything we were doing was with a single table. It might well have been easier to do in Excel. Now we're going to get to what is the real power, I think, of relational databases, and that's joins. So a join is how you take two tables and link them together. So we're going to start with this simplest of joins, and that is what's called the cross join. Now, what a cross join does is the table on the left and the table on the right. Now, I usually, let me stop there for a second. I usually break these up into multiple lines for easy reading. But when we talk about the left and the right, you can view them as if they were on the same line like this. So context cross join calls. So the way it works is the table on the left, it reads the first row from the table on the left. Then it goes to the table on the right, and it joins that together with every row of the table on the right. So you end up with essentially multiplying these two tables together. And when I say, again, we haven't supplied an order, so when I say it actually starts on the left and goes to the right or whatever, that may or may not technically be accurate, but that's the way we can visualize it, that it multiplies, every one together. So we can see here, it looks like in this one, it actually, without the order, we would actually view it starting on the right. But what we can see here is, okay, we have every one of these contacts, and they're all joined to the same call. Call ID number 1. Then we get down here to Miranda again, and we have another set of these, where now it's call 2, then it's call 3, and it's call 4. So we end up with a total of 76 rows, which we come up with 76 rows because we have 19 contacts. We have 4 calls. 19 times 4, 76. So the cross join just mashes every possible combination of these things together. Now you might be asking yourself, that doesn't sound too useful. Why would we ever do this? And you're right. We actually will very rarely do this. But we're starting here because that is the conceptual underpinning of where all the other joins come from. So what we usually want is something called an inner join, and you can leave the word inner off. So usually we just say this join that. Now what this type of join does is it adds a condition to decide how we connect these rows together. So with this one, we're going to say, I want to join the contacts table to the calls table. But the way I decide which rows fit together and which rows don't is when the ID column on the contacts table equals the contact ID table on the calls table. And you'll see you're probably familiar with this that syntax from Python. I'm guessing you've probably seen it there. In this case, what it's referring to is it's table.column. So the table contacts ID dot column ID equals table calls column contact ID. And if we run this, we only get those 4 rows where they match up. We made 4 calls. Those calls were to, as it turns out, just 2 different people. And it gives us all the columns from each table.
And is this a new table in of itself, or are we changing the data in one of our calls or contacts?
We are not changing any data on disk. When we say, is it a new table, that's actually kind of an interesting way to put it. When we do a select thing, where one of the terms you might see if you run into, or if you look into the more math or theoretical basis for this, you'll sometimes hear this referred to as like a projection. But one of the cool things about SQL is the result of a query is a table. It's a very short-lived table, you might say. But most any place that we need a table, we could use a select statement there as well. So I guess the short answer to your question is no, we're not changing anything, and no, we're not creating anything permanent. But in a certain sense, this is a new ephemeral table. You know, it only lives for the length of the query.
So it's like a print statement, kind of.
Sure. Well, I mean, we're printing out the result of it. I mean, it's not a print statement itself, but yeah. I mean, it'd be kind of like if in Python, if you have variable A and variable B, and you say print A plus B, well, then there's essentially a new variable, we'll say C, that exists there momentarily, but it's never saved anywhere. It just kind of exists as part of the calculation, but there is something there. That would, I guess, be maybe how I'd explain it a little bit. But I mean, that type stuff gets a little more advanced for when you'd actually want to do this. Here is, we did not make any changes to any of the data that we've stored. And part of why we started with the cross join is, you notice these 4 rows here. If we were to go back and do the cross join, let's see, those 4 rows are here. It's just there's a whole lot of other rows we don't care about. So like this first row is one of them. Then we actually want to ignore all of these. Then this second one here, I think this is the row. And then we want to ignore all these other ones. Then this one, then this one. Again, it's because, you know, those columns where these values actually match. And that on clause is a Boolean expression that filters, you know, only rows that pass that filter get passed through. And it's conceptually easy to think about with the cross join. Okay, this is like all this data that's here, and the on clause determines which rows actually flow through. So joins are usually pretty confusing to people. You generally have to see it a few times for it to make much sense. Anybody got any questions on this?
If we wouldn't have done that that association with the foreign key, would this select statement work then?
Yes, it would work.
Oh, because we're using contact ID, not ID, correct?
Well, the reason it would work is the foreign key constraint, all that does is tell the database to make sure that those rows always match, that there's always a match on the other side. But this condition here, this is just a true or false condition here. You know, we could say anything here. You know, if we wanted to just say true, well, this is essentially going to act like the cross join again. You know, if we on true, or we could say on random is greater than 0.9. It'll randomly give us a few rows. Now, obviously, we wouldn't actually do that. Or we could say false and no rows come through. So it really is just a matter of, is this condition true or false? Where did I go? There we go. So even though the database, even though we had not told the database that those 2 columns on those 2 tables had some sort of special relationship that it should make sure is always enforced, as long as those numbers there are comparable with each other, we could still run it. Any more questions? Yay, nay? Okay.
One of the guys was asking about like different types of logical expressions yesterday could you like compare the types of joins to the types of logical statements? So like a inner join is like an and statement, and an outer, or like an outer join would be like an XOR statement.
You might be able to think of it that way. I mean, to be honest, I would, if you were going to think about it in those terms, I would more think of an inner join as the intersection of two sets. You know, kind of like a Venn diagram thing would be more how I would see that. The cross join is the union. Well, actually, that's not even the case either, because that's actually a multiplier. I'm not even sure what would be a what would be the,
cross join is just a Cartesian product, so it's
yes, that'd be the word for it there.
Yeah. But I was trying to come up with like the outer join where of the Venn diagram, where all of the things on the left that are not on the right, and all of the things on the right that are not on the left.
Right.
That would, if you, I guess, the Venn diagram is just a better way to visualize it, than try and worry about logical expressions. But I guess you could use any one of the logical expressions to produce the result you needed.
Yeah, maybe. I mean, I'm not sure. I'm not sure if Boolean logic exactly works there, because I mean, it really is set-based operations.
Okay, gotcha. Interesting. Thanks.
Mm-hmm. So, you know, this next thing is actually a little more than I can fit in 3 minutes. So why don't we go to lunch, and we'll resume at 1 p.m. Central Time. So an hour and 3 minutes from now.
Awesome. Thank you.
Yep. All righty. See you in a bit.